Today we're going to be looking at triangles. To start us off, we're going to watch this clip, and it's from The Wizard of Oz. Guessing you guys have seen that, but if not, welcome to The Wizard of Oz. And I want you to see what happens when the scarecrow gets a brain. Alright, so number one, as a math person, I love that when somebody gets a brain, the first thing they know is math. I mean, I think that's pretty awesome. But I also want to know, was he right? So let's look at what the scarecrow said. He said, the sum of the square roots of any two sides of an isosceles triangle is equal to the square root of the remaining side. Then, oh joy, rapture, I got a brain, whatever. But let's decide if he was right. So we need to start with reminding ourselves what is an isosceles triangle. So when we talk about triangle types, we can break them down in different ways. We can talk about their side lengths, and we can also talk about their angle measures. So when we're talking about something like an isosceles triangle, this has to do with the side lengths. So there's three ways of breaking down a triangle based on the side lengths. So let's first off talk about when all the sides are different, it's called a scalene triangle. And so you can see that in this first picture here, that these little tick marks show me that here's one length, here's another length, here's a third length. The second one over in the upper right, I have these two sides that both have one dash mark. So that shows that those two sides are equal. So a triangle with two equal sides is called an isosceles triangle. So that's what the scarecrow is talking about, two sides of the same isosceles. Our last case is when all the sides are the same. That's called an equilateral triangle. That one makes sense, equal, so they're all the same, equilateral. So two sides the same, isosceles, three sides the same, equilateral, and all different scalene. When we have this other way of describing something called the angle measure description, then we're looking inside to see what do the angles look like. We know that the sum of the degrees of a triangle is 180. We've talked about that before. So then we just want to break down, well, how do we get to that 180? If the triangle has a 90-degree angle, it's called a right angle. And the triangle is then called a right triangle. You could only have one 90-degree angle. You couldn't have more than that because 90 and 90 would be 180, and then you couldn't have a third. So know that when you have a right angle in a triangle, it's just one of the angles is 90, and then the other two will add up to the other 90. A triangle that has all three angles less than 90 is called acute, and you can see that in this picture here, little, little, little. So they're all less than 90, that's acute. And then a triangle with one angle greater than 90 is called obtuse, and you can see in the picture I pointed to the obtuse angle. So I have that one that's bigger than 90, and then the other two are less than. So we had our side lengths, scalene, isosceles, equilateral, and now we have our angle measures, right, acute, and obtuse. The second thing you probably kind of alluded to from listening to that video is something called the Pythagorean Theorem, and it probably sounds familiar. Most people have heard it at some point before. But here's what the Pythagorean Theorem says. It says, if a triangle has a right angle such that C is the side opposite the right angle, called the hypotenuse, then the sum of the squares of the other two sides, A and B, is equal to the square of C. I know that just sounds like a lot of stuff, so it's probably a lot easier just to say a squared plus b squared equals c squared. Very important that C is that longest hypotenuse side, and then A and B are the other two sides. This really works in a biconditional kind of way. So that what that means, it says if I had a triangle where a squared plus b squared is equal to c squared, that tells me the triangle is a right triangle. It also says, hey, if I know it's a right triangle, then I know that this relationship will exist, that a squared plus b squared is c squared. So it's important that it goes back and forth and is a very strong theorem. In that, and I have a separate little paper on it later too if you just want to look at the Pythagorean triples. It's posted right under this on our homepage or on our weekly module page, that there are things called Pythagorean triples. So what these are they're just integer solutions to the Pythagorean theorem. They're things that we know work, and so if you notice that they're happening, I'm not saying you have to memorize them, but if you know them, it does make life easier sometimes. So examples, easy, 3, 4, 5. 3 squared plus 4 squared is 5 squared. 3 squared is 9. 4 squared is 16. 9 and 16 becomes 25. Another one, 5 squared plus 12 squared is 13. So 5, 12, 13 is a triple. 5 squared is 25. 12 squared is 144. 13 squared is 169. 25 plus 144 is 169. There are a ton of examples. It's interesting to note, once something works as a Pythagorean triple, then any multiple of it does. So like I know that 3, 4, 5 is a triple. If I multiply that by 2 and have 6, 8, 10, I know that's also going to work. 6 squared plus 8 squared, so it's 36 and 64, it makes 100. You could do it by 10. If I multiply 3, 4, and 5 by 10, I get 30, 40, and 50, and it also forms a right angle. So sometimes that's kind of nice. It's kind of clever. If you notice that pattern happening, you can quickly get the answer to solving a Pythagorean theorem kind of problem. So if you notice it, awesome. If you don't, you can do the math and it's still going to come out just fine. So let's look at an example. In this triangle, 5 is the hypotenuse, and I'm just showing you again this Pythagorean triple that you can see 3 squared plus 4 squared is 5 squared. So 9, 16, 25. So let's try to find this one. This one says find the value of C, and you can see I have a base of 12, a height of 16, and I'm missing that hypotenuse C. So I set up 12 squared plus 16 squared, and that's going to give me C squared. So 12 squared is 144, 16 squared is 256. I add that together, it gives me 400. Then I want to take the square root of 400, which is 20. Notice this was a Pythagorean triple. If I took 3, 4, and 5 that we've talked about before and multiply it by 4, I would get 12, 16, 20. So you can see we did the math and we got the 20. We could have done the multiply by 4. I got the 20 as well. All right, so let's look at this one too. I have find the value of the hypotenuse. And this right angle is interesting because it's also an isosceles right triangle. So the base and the height are both 4, and I'm missing that side C. So we're going to square 4 twice. So I have 4 squared is 16 plus 4 squared is 16 gives me 32. 32 doesn't work out perfectly. It is not a perfect square. So in the calculator, sorry, I put a double approximately there. But it does tell me C is about 5.66. So let's go back to what the scarecrow said and use it with this isosceles triangle that I just showed you. So the scarecrow said the sum of the square roots of any two sides of an isosceles triangle is equal to the square root of the remaining side. Okay, so our last example was an isosceles triangle, and it says if we take the square roots of two sides, so let's take the square root of 4 and the square root of 4, then it should be the square root of the other side, which we said was 5.66. Okay. So square root of 4, square root of 4, that's what I'm looking for, should be the square root of 5.66. Well, because I don't know it, square root of 5.66 is 2.38. Square root of 4 is 2, square root of 4 is 2. 2 plus 2 is definitely not 2.38, so it looks like the scarecrow didn't get the brain after all. Kind of love that as a professor, because what it says is when someone hands you a degree and you didn't do the work and sit through the class to get the knowledge, you don't know anything. It really shows you, I know I'm just pushing from a child's movie here though, that it does matter that you learn something in college and we expect you to know something good at the end, and so I kind of like that it wraps back into paper without the background. Doesn't mean anything. All right, so let's keep going. I want to find the value of x, again the hypotenuse. So once again we're using Pythagorean theorem. So that base of 12, I square it, and then the height, 9, I square it. I have 144 and 81 gives me 225. I took the square root, and I got 15. So let's talk about application, because I think that's really why we like math in general, so we can apply it somewhere. So let's say we had a painter, had a 13-foot ladder, and he's painting a house. But there's bushes around the house that force the painter to place the base of the ladder 5 feet from the base of the wall. So picture, you can't get right on top of it because you have that problem that the bushes are in the way. You can't set your ladder there safely, so you're going to have to go over them and say, well, how far up is he going to be able to reach now? How far is he going to be able to rest this ladder? Will he be able to get high enough to paint the house? So what I'm looking at is I have this x is how high I'm trying to go. So that's unknown. So I'm going to do x squared. But this 5 feet, I know that's how far I got to place it back. So that's squared. And then my ladder was 13 feet. I can't change that. So x squared plus 25 is 169. When I move the 25 over, it gives me 144. And I take the square root and it says 12 feet. So by placing it 5 feet out, I lose a feet in height. That's not too bad. Another thing we can talk about as we're looking at triangles is the idea that triangles always add up to 180 degrees. And so if we know 2 of the angles, we could find the missing third one. So you can see in this triangle below, I have 57 degrees as one angle, 54 degrees as a second, and then a missing angle of x. So I want to find that value of x. I know all 3 of them are going to add up to 180, so I put 57 plus 54 plus x to give me 180. I can simplify the 57 plus 54 to get 111, and then when I subtract 180 minus 111, it tells me the missing angle is 69. All right, so let's do it again. I just changed the shape, made it look a little different. This one's obtuse. So I have x, 95, and 23, again, going to add up to 180. So the 95 and 23 gave me 118, so I subtract 180 and 118 to get 62. Okay. Here's a different look, and on this one, I gave you an exterior angle of 65, so you can see that down with that straight line. It tells me the outside one is 65. I have an inside measure of 37 and a missing angle of x. Well, we can still figure this out. So we're going to start with the 65 and say it forms a straight line. So I can see right here, if I wanted to, I can say, here's the one I can find from doing this straight line part. So I know that 65 and something adds up to 180. So I did 180 minus 65 to get 115. So now I know this one is 115. Okay. Then I have 115, 37, and x would be 180. So 37, 115 is 152. 180 minus 152 is 28. So this one is 28. Okay, so your turn. I want you to try this one. Same kind of deal. I gave you an exterior angle, and then I just labeled it a 1 instead of an x this time, but I want you to try to figure out the measure of 1. So definitely pause me right now, try it on your own paper, then come back and see how you did. All right, so let's start with looking at the answer. So same thing like before, I can figure this angle out by looking at the straight angle, and I can say that I know 180 minus 130 should give me 50, because I know these two have to add up to 180 altogether. Now that I know this one is 50, this one is 90, that adds up to 140. So I do 180 minus 140 gives me 40. So let's try the same thing with an isosceles triangle. Not really anything different, it's still going to add up to 180, but the difference here is I'm missing 2 of the angles. So I decided let's just call this missing angle x. So this would be x, and this also would be x. So this says x, and 36 is 180. When I take the 36 from the 180, I got 144. I divide it by 2, and it says each of these is equal to 72. So again, change the triangle. So now we have a right triangle. And this one, the only one I know is the 90. The others, I just have some equation or some like expressions to get me there. So, but I do know, again, the 180 is the consistent for triangles. So I have 2x, I have 90, plus 3x minus 5, and that should be 180. So you can see here I combine 2x with 3x to give me 5. I did 90 minus 5 is 85. I subtracted the 85 from 180. Okay, so now I'm down to this point that says 5x equals 95, so x is 19. Again, just throw it in my calculator. Big difference here is pay attention to, was I looking for x? Well, really, I was looking for these angles. So this first one says 2x. So I need to do 2 times 19, that's 38. So this one is now 38. Then the other one, I need to do 3 times 19 and subtract 5 to give me 52. You could have also said 38 and 90 is 128 and subtracted 128 from 180, and it would also give you 52. So that's a nice check too to make sure they all add.